Hi, so we are going to talk today about how to solve compound inequalities that are connected with OR. This is what we call a disjunction. A disjunction is when you have inequalities connected with OR. And a disjunction is always going to be true as long as at least one of those inequalities is true. Possibly both, but at least one is going to be sufficient. So we have some simple inequalities here that comprise that. So we subtract 3 here. And we're going to have x is less than -2. We basically solve each inequality individually, and then we kind of look at them together. So plus 2, and x is going to be greater than or equal to 5, right? It is important that it's OR because the other ones have AND and they are different. And when you solve this, before you finalize anything, I suggest you use a pencil. So we want to be less than -2. Right, so we're here, and we want to be greater than or equal to 5, so we're here, right? So from 5 to the right and from -2 to the left. So as long as one of those is true, is going to be the answer. So this is actually what's going to make up your solution. So you're going to put a closed circle at 5, you're going to have to put an open circle at -2. We are shading to the left of -2 and to the right of 5, and this whole thing is going to be the answer. So you do have two separate intervals here. So when you write interval notation, you're going to have to put it together. So the left side here is -infinity to -2 with open. Then we're going to use the union symbol, and then we're going to go from 5 with a bracket because it's closed to +infinity. Okay, so disjunction is going to be true in any part that is shaded. So we have to in this problem we have to shade two separate parts, and in any one of these parts the solution is going to take place. Let's take a look at our next example. So again, we're using very basic inequalities here. So we divide by 5. That's going to give us x is less than or equal to -2. And here we're going to add 1. And x is going to be less than 3. Okay, so here's what we have here. We have inequalities that are going to end up going in the same direction. The one on the left here is going to go from -2 to the left. And the one on the right here is going to go from 3 to the left. So if you think about this, when you are going to graph this, which is going to be from 3 to the left, this here is going to contain that in it already. So as long as something is shaded, this is what we're going to be using. So the graph here for this solution is going to go from -3, that's going to be open, and then it's going to go all the way to the left. I'll explain again what I mean in just a moment. So there is no need to graph x is less than or equal to -2 separately, because x is less than or equal to -2 goes from here to the left, and it's already included in what we already shaded. Okay, so as interval notation, this is going to go from -infinity to 3 open. Let's take a look at example 3. So we add 3, get 2x less than 8, divide by 2, and we have x is less than 4. Now remember, be careful, we're dividing here, so watch out, but we're dividing by a positive number, so it's good. Here we're going to divide by a negative number. That means the sign's going to flip, so x is going to be greater than or equal to -2. So let's take a look at this. So here we're going to go from, on this one, we're going to go from 4 to the left. Here we're going to go from -2 to the right. So imagine this, imagine we're going from -2 to the right, and we're going from 4 to the left. We are actually going to end up shading the entire number line. So this whole thing here is going to give you all real numbers, because the whole number line is going to end up being shaded. And of course our interval notation here is going to be representing all real numbers, so it's going to be -infinity to infinity. A couple more. This one, So we're going to do add 1, 2x is greater than or equal to -8. We're dividing by 2, positive number. X is going to be greater than or equal to -4. Here we're going to subtract 2. We're going to have negative x is greater than 5. We have to divide by -1, and it's going to give us x is less than -5. So what do we have? We have greater than or equal to -4, so we're going to go this way, or less than or equal to -5. They're not connected in any way, they're going in the opposite directions, which is okay. There's nothing wrong with that. So from -4, which is going to be closed, we're going to go to the right, and from 5, which is going to be, -5, which is going to be open, we're going to go to the left. So this is what we're going to get. So we're just missing that little part between -5 and 4. So again, we have to join two separate intervals here. And it's going to be -infinity to -5 for the one here. And it's going to be open, so parentheses. And it's going to be union, a bracket, because this one's closed. From -4 to positive infinity. And the last one here is, so we're going to add 3, and that's going to give us 2x is less than 8, divide by 2, positive number, so x is less than 4. Here we're going to divide both sides by -3, which means we have to flip the sign, so x is greater than 4. So we have x is less than 4 and x is greater than 4. Sometimes students get confused with things like this, but 4 is not included in either one of them, right? Because one of them says less than 4, the other one's greater than 4. So that means 4 is going to be open, but it is the same boundary point for both of them. So it sounds a little interesting because you are going to, it looks like you're going to be shading almost the entire number line except the 4 itself. So when you do this, you are going to have to exclude 4. You can't say all real numbers because 4 is not included. The way we write that is going to be -infinity to 4, open, and then we're going to do union, and then from 4 also open, positive infinity. This is how you do it with compound inequalities with or. They're called disjunctions. I hope this helps.